Hello everyone. So this is the fourth lecture of my Serenade series. So in this lecture we'll see a few basic things about S parameter, and then we'll try to simulate short circuit and then open circuit condition. We'll try to get our result by theory, and then we'll try to match that result with our simulation. So before starting, I want to say one thing. The S parameter I am discussing here, these are only the abstraction. If you go mathematically deep, then S parameter it's a 1 or 2 hour lecture. But here I am giving you just a gist of the S parameter so that you can you become comfortable with this this software, because we are dealing with S parameter only, and if you don't know, or if you have forgotten the basics of S parameter, then I think it will be difficult you to follow. So that's why in this lecture, firstly I will quickly refresh the basics of S parameter, and by this I think you will appreciate all the result we were getting in previous video and in the upcoming videos. Okay, fine. So this is our circuit. It could be anything. It could be a low pass filter, it could be a high pass filter, it could be an amplifier circuit, and in our case it was a transmission line. If you remember, we were using a transmission line and we are using a matched load. So this could be any circuit. That means you can analyze any circuit using S parameter. So, and we are dealing with RF, so RF frequency, so we'll have incident wave, reflected wave, and many things, transmitting wave. So this is our circuit, this is our black box. We don't know what inside of this black box, and let's assume that we have given a signal to this circuit, and this signal we'll call it incident wave. So from basic electromagnetic theory, we know any wave, when it got incident to a circuit or to anything, any surface, then it should get reflected. Perfect. We don't know the reflection wave. We could estimate the reflected wave if we know the reflection coefficient, and we know reflection coefficient is given by gamma in. So for example, if we incident a wave of 1 watt of power and our reflection coefficient is 0.5, that means half watt of power will be get reflected. Perfect. And another half watt of power will be utilized this circuit, and this circuit will use it as per its requirement and will get a transmitted wave. Perfect. But see, we were using 1 watt of power, but we are getting only 0.5 of that power which we have used. So that means efficiency of our circuit, it's getting lowered, and in practical scenario we want as much of power as we can feed to our circuit, but here it's a very worst kind of circuit because 0.5 of the power is getting reflected. So is there any way to know the relationship between incident wave, reflected wave, transmitted wave without knowing the circuit or the black box? Fortunately, answer is yes. And there we have the S parameter. Like we have Y parameter, Z parameter, ABCD parameter, or hybrid parameter. So this is our incident wave. We are getting a reflected wave, and we have S11, S12, S21, S22. You are familiar with S11 because in my previous last 2 videos I have showing you only the S11, and the reason is that I was using only port 1. If you remember, I was terminating the other port with a resistance, so I was using only one port. That's why I was getting only S11. Your circuit could be of more than 2 port also, like it could be of 3 port, like in your power divider it's of 3 port. It could be of 4 port also, like we have VLC. So port could be of any number, and according to that port our matrix of S parameter will grow. So but we'll keep ourselves limited to 2 port for now. So this let's talk about with respect to port 1. Perfect. So what is S11? S11 is your reflected wave divided by incident wave. You have a reflected wave here, you have an incident wave here, and if you have reflected wave divided by incident wave, then it is your S11, and you could actually recognize this, that this is nothing but your reflection coefficient. So safely we can say that S11 is just nothing but our reflection coefficient. Perfect. Or it could be also called a return loss if we use this formula. This is don't be afraid of this formula. It is like, see, here we are using the magnitude of S11 because inside log we need to use positive values only, so we are taking magnitude of S11, and return loss is in the sense of power, and our S11 is nothing but it is voltage divided by voltage or current divided by current. So to get the power thing we need to square it, S11 square, but this square will come front and it will become 20 log, and generally to convert anything to dV we need to use 10 log, but here we are using 20 log because S11 is in the voltage or in the current form, so we need a square term, and that square term is coming in the front and we are getting 20 log. And why this is this minus sign here? See, we need return loss as a positive parameter. Perfect. But S11 you see here, reflected wave will always be less than incident wave. In practical scenario, reflected wave will be always less than incident wave, or if it is forced, then reflected wave will be equal to incident wave. That means S11 could be 1 in magnitude, could be 1 or less than 1, and inside a log if we get something 1 or less than 1, then it is negative in the sense. So to get return loss as positive, we are using a negative sign explicitly here, just for mathematical easiness. Perfect. So this is our S11. Well and fine, we know what is S11, we are using it from last 2 videos. So this is your S11. Now what are these 3 things? So this is your S21. S21 is like gain. You can say S21 is gain because see here what we are doing. We are using transmitted wave divided by incident wave. But if your circuit is passive, then for sure we won't be getting gain. So we used to use another term which is called insertion loss. It is used in the passive term, like if you have a passive circuit, then we won't be getting any gain. Perfect. So we called it insertion loss, and again insertion loss will be like S21 will be 1 or less than 1 because transmitted wave may be 1 or less than 1, as we have no active circuit here. So transmitted wave can't go more than 1 if our incident wave is of 1 unit of power. So here again we are using that negative sign, and it is called insertion wave. So we know S11, we know S21, but what other these 2 things? And I think few of you might guessed it right, that these 2 will be with respect to port 2. Now we are seeing with respect to port 1, like we are using port 1 as our primary port and port 2 as our transmitted port. But if we reverse these 2 things, then we will get S12 and S22 in the picture. And if your circuit is symmetrical, then S11 will be equal to S22 and S12 will be equal to S21. So let's see it. So here we are using port 2 as our primary port. Our incident wave is going through port 2, and we are getting a reflection in port 2, and our transmitted wave is coming out of port 1. So S22 will be reflected wave in port 2 divided by incident wave in port 2, and similar to my previous slide, we'll be getting these terms, and S12 will be the similar, we'll call it gain if it is amplifier, and in passive sense it will be called insertion loss. So these things are with respect to port 2 if we consider our port 2 as primary port.